Okay, here's a question about an open-topped water tank. They've put that in bold, so that must be important. You have got an example rather like this in your notes, but I'd suggest you actually take all the hints in this question and see how many of the marks you can get without any help, because on this one, although it's a bit tricky, they give you lots and lots of re-entry points. The first thing we've got to do is show that this equation here is true. Now, because it's shown that, that is the end point. So just staring at that won't do you any good at all. Forget all about that and look for your starting point, which must be to do with this given number of 54 square meters. And that's the surface area of the base and 4 vertical faces. So looking at your diagram, the area of the base, well, there's only one of those. There isn't a top because it was open top, remember. And there are 4 vertical faces, so we're going to have 1 times the base plus 4 times the area of a vertical face, and that's got to equal 54. And if we set that up, we should be able to simplify it to this equation here as our endpoint. If you couldn't do that, it's not a problem really, because this is a re-entry point here. Hence means starting from what you just did, express h in terms of x. So you just need to make the h the subject of that particular equation you ended up with in part 1, and that should be this mark here. And that leads on, because we've got another hence question, to showing that the volume equals this. So you've got to go back to your diagram and think, how would you work out the volume? It's a cuboid, so it's a fairly simple calculation with the measurements. And that will have h's and x in it. The expression we're aiming for here has just got x's in. This again is our end point, because once again it's a show that question. So this is an end point, but we need to end up with x's and not h's. So your first attempt will have h as well as x's in, but then you substitute in your h in terms of x from the previous part of the question, and then you've just got to do the algebra that links that to the given answer. Try to do that without faking, and you've got to do all of that for 1 mark. However, if you don't get that 1 mark, it's certainly not the end of the world, because guess what? All of the rest of the question is based on this expression here. If you couldn't get the marks up to this point, this and this are big style re-entry points, so complete the question even if you couldn't do part A. dv by dx, 2 marks for differentiating this, so 1 mark for differentiating the first term and 1 for the second term. Use the recipe from chapter 5. Verify that v has a stationary value when x equals 3. Now normally for a stationary value you'd leap straight into saying stationary values are when dy by dx, or in this case dv by dx, equals a particular value. And you can do that, and you can solve dv by dx equals that value using your answer to b.e1. However, this says verify, which means on this particular occasion we're allowed to actually assume the answer. We're allowed to start with x equals 3, we're allowed to substitute it into dv by dx, get an answer, we're aiming for a particular answer. When you get that, you must comment on it and convincingly explain why that means it's a stationary value. And then for the last part of the question, find d2v by dx squared. So we've differentiated once here, we need to take our answer for dv by dx and differentiate again. And to tell whether we've got a maximum or a minimum value, we need to know the sign, whether that's positive, negative, or possibly 0, though it won't be 0. When x is 3, we're going to be substituting x equals 3 into our d2v by dx squared and commenting on the value you get and making it very clear whether that means it's a maximum or a minimum. And that's the last 2 marks.